there any questions from yesterday's stuff or any questions in general about anything?
Yeah, I have a question from
Yes.
yesterday's notes. It's the last question, the vector subtraction.
Yeah.
I think the negative, you got the negative initial velocity.
This one?
Yeah.
Yeah.
There, for the negative initial velocity, you put 32 degrees south of east.
Yeah.
But shouldn't it be east of south?
Oh, yep.
Right, if you flip the directions.
100%. Yep.
Yeah.
Because this becomes east, this becomes south. Yep.
Yeah. So I did it again. I got a different answer.
Perfect. You're smarter than I am. Yeah, no, I totally messed that up. You're right.
Okay, I just wanted to know. Yeah, thank you.
Yep. That's awesome. First day, first mistake. Great. Any other questions from the worksheet?
Could you go over question 12?
Yes. And just to note, like the answer key is not correct for some of them, especially like the first ones. Like if you look at B says west of south, but this is definitely not west of south. That's like northwest. So there's some issues with that. Number 12, you said, right? Okay, so what is the acceleration of a ball that bounces off a wall in 0.3 seconds if its incoming velocity, so VI, is 60 meters per second, and then its recoil velocity is 50 meters per second. Now, if I make the VI 60, the VF has to be negative 50 because it's going to go towards the wall, hit the wall, and then bounce back. And so one of them's positive, one of them's negative because they're opposites. And so what is the acceleration? Well, acceleration is VF minus VI over time. And so if I have an initial velocity of 60 that way and a final velocity of 50, it's going to be VF minus VI. So VF is negative 50 minus, and because this is a vector, you're adding the negative VI. So if VI is positive that way, then the negative VI becomes left. So it looks like this. So VI, this is VI, VF is 50, like that. So VF minus VI would be VF minus, so you're adding the negative 60, which is that way. Okay, so it's 50 minus 60, like that, over 0.3. So that's negative 110 divided by 0.3, which is that the right answer? 367. Like that makes sense. Yeah, 367 meters per second squared. Okay, does that make sense?
Yeah, thank you.
Yeah. Any other questions?
You said the answers for number 1 and 2 are kind of wrong.
Yeah.
Can you maybe give us the correct answers? Do you have other key?
Yes. Bear with me, this might take a little bit, but okay, so 5.5 cos 20 is your x. So this is 5.17 sine 20 1.88. I should have done this beforehand. 1.8 sine 60 negative 1.56. So for B, because it's west of south, so that would be that way, 60 degrees, like that. The x component is that one right there. And so it's actually sine in this case. I know that all the examples I did yesterday, x was always cos. And so it depends on how you draw it. So it's not always cosine. 60. This is negative 0.9 north of west, 2.5 coast 36. Negative 2.02, I think. Yeah, that makes sense. 2.5 sine 36 is 1.47. Okay. So then you can just add all those together. So if like 5.17 minus 1.56 minus 2.02. So for number 3, it's 1.59.
Sorry, can you explain B again? How?
Yeah, so for B, let me draw it bigger over here. So 60 degrees west of south. So that's like that. So this is south, this is west. So 60 degrees west of south is that one.
Mhm.
And this is 1.8 centimeters. So your x, your dx is this side. And so if you think about like that's the opposite side, that's the hypotenuse. So you go sine 60 is opposite over hypotenuse, so dx over 1.8.
Oh, mm-hmm.
And so then dx would be 1.8 sine 60.
Okay, got it. Thank you.
Yeah. And because it's going to the left, because it's west, that's why it's negative.
Maybe.
And
Okay.
it's south, so that's negative as well. And then, yeah, so we'll do 1.88 minus 0.9 plus 1.47. This would be 2.45. And then for this one, you just add them together like that. And then I'm not going to do the rest. Okay. Make sense?
Yes.
Cool. Any other questions?
I couldn't solve the 7 question.
Number 7?
Yeah.
Okay. So the first one, you know, like, okay, yeah, 7. 8 meters north. So that's just going to be that, 8. And then plus 5 meters, 30 degrees north of east. So that's going to be something like that. Let's make this 8 bigger than the 5. So this is 5, and this is 30 degrees. And so if you, it's probably easier just to use components because you only have a y component in your first one. So it's just going to be like the resulting vector d, let's call it r, drx is going to be whatever the x component is of 5, 30 degrees north of east. So that's going to be 5 cos 30. So that's going to be 4.33. And then this part right here is 5 sine 30. So that's 2.5. So that gives us a dry of 10.5. And then that's what you're left with. So you just have, come on, pen, your 4.33 and your 10.5, right? Because 5 sine 30, it's been a while. Yeah, sine 30 is 0.5, so it's 2.5. And then you just use Pythagoras for this. Plus 10.5 squared. Square root answer, so this is 11.4. And then, is that the right answer here? 11.3, rounding down. That's okay. And then the angle, come on, 10.5 divided by 4.33. That's tan, would be 68 degrees. Hopefully that's right.
Oh,
Oh yeah, okay. So I got 68 degrees,
yeah.
but I'm going north of east.
That's
So
right.
68 north of east, but this is saying it's 22 east of north. So 22 is like the complementary angle. I think that's what it's called.
Oh, but Mr. John.
Yeah.
Can you send me the videos? I sent you the email.
Sorry, say that again.
Can you send me the first lesson video?
Oh, you have access to the team, right?
But yeah, I accessed team yesterday.
Okay, let me show you where it is for a sec, okay?
Yeah. So
Okay, so if you go, because there's a few new people here too. If you go to our team, the first video, so the videos are posted, like, so that up here is lesson 1.
But
yeah, the first video.
I didn't get it on there.
Pardon?
I didn't get any videos up there.
If you are you clicking on it though?
Yeah, I'm on.
Oh,
I'm on there. Yeah.
If you click on the replies
on my teams,
you see how I clicked on the replies and the videos there? Can you try that?
Yeah, I tried that, but there's no video.
Video still doesn't show?
Yeah.
Okay, I will remind me at the end of this call to share the video directly with you then. I'll try that.
Thank you.
Okay. How to go back to this? I don't know how to go back to the call. Oh, here we go. Yeah, that works. Okay. Okay, let's do lesson 2 is a lot of the same stuff. We're just applying like word problems to it. So it's not anything new, I don't think. Okay. So these are navigation problems because they deal with vectors and like changing vectors and stuff like that. And there's only 2 examples here, so it's kind of short. And then we have two worksheets for this one. Oh, before I forget. So we're using like cardinal directions, like 30 degrees north of east and all that stuff. Some universities will actually use like your 360 degree scale. So it'll be like, if it says a plane is traveling 150 degrees at a certain speed, well, that would be something like this. So 150 degrees is this right here, 150 degrees. Okay, so it goes 0, 90, 180, 270, and then 360. Okay, so it uses those. So like if I were to say 40 degrees south of east, which is this one right here, that's the same thing as 320 degrees. Okay, does that make sense? Hopefully. Okay, so the first problems are river problems. These are very common in physics. A kayaker can paddle her kayak at a speed of 6.4 meters per second in still water, and she's attempting to cross a 150 meter wide river that's flowing 4.2 meters per second west. So what this means is that the kayaker, wherever the kayaker goes, her speed's going to be 6.4. Okay, you're kind of making an assumption that it's instantaneous speed. There's no acceleration or anything, but that's always going to be her speed. So there's options for this kayaker. She can either go directly across the river, she can go upriver, or she can go downriver. So the first case, if she heads directly across the river, so she is pointing her kayak directly across the river, she's going to end up downstream. Okay, if you've ever been on a river bed, you can see that things flow downriver. So here's the river, and she's going to start her kayak right here and point it in this direction right here. She's going to point directly across the river. But as she's kayaking, and keep in mind that her kayak's always going to be pointed that way. As she's doing that, the river is going to bring her kayak downriver. Okay, it's going to push it downstream. So her actual motion is going to look like if I draw the kayak, it's going to be like that. Okay, so she's going to end up down here somewhere. Okay, now she's pointing directly across the river. So that means the speed at which she crosses the river is 6.4 meters per second. Okay, and then the speed at which she's being pushed downriver is 4.2 meters per second. Now this is very challenging concept for people. The speed at which she crosses the river is unaffected by the actual river itself because she's pointed directly across. Okay, it doesn't matter that she's being brought downriver. Yes, her total speed will be more. Like if you were on the side of the river, you would see her going faster than 6.4 and faster than 4.2. You would see her doing this velocity right here. But it doesn't matter in terms of perpendicular vectors. Okay, because they're perpendicular, they are unaffected by each other. Now, if she starts heading upstream, that means she's part of her velocity is going to cancel out the velocity of the river. And that's what we're going to do in question B. But right now, all she's doing is crossing the river, and that's completely unaffected by the river itself. It's as if there was no river there. Okay. So what we want to know is how far downstream she'll land. So we want to know this distance from here to here, this distance. And in order to find that, because we have our velocity and we're trying to find distance, we need to have time. Okay. And so we're going to have to find the time. And I'm hoping you guys all know this formula, v equals d over t for constant velocities. So we're going to apply that to her crossing the river directly. So the river itself is 150 meters wide. And so now if you look at these two, we have our velocity, we have our distance. Now we can find our time. Okay, so the time will be equal to distance over velocity. So 150 divided by 6.4, which is 23.44 seconds. Okay, so that's the time it takes her to cross the river. In that time, the river's bringing her downstream. Okay, and how far downstream is d equals v times t. And so the river is going 4.2 meters per second times for 23.44 seconds. And so that's going to be a distance of 98 meters. We'll just leave it at 98. There's some decimals, but whatever. Okay. Does that make sense? I'm hoping it does. I'm hoping you've done, like you all did projectiles, I'm hoping. And so projectiles was where a ball would like roll off a table out of a certain velocity. And in the x direction, that velocity remained unchanged. And in the y direction, it accelerated. Like it accelerates downwards. And those are completely separate. They're completely separate motions, right? Your x and your y are completely separate. Well, the same is true here. If your vectors are perpendicular, they don't actually affect each other. Okay, so what heading must she take in order to land directly across the river? So now, here's our river. Any questions about A? Okay. So now if she wants to head directly across the river or land directly across the river, if she starts here and the river is flowing west, she has to head this way so that by the time the river pushes her back down river, she ends up directly across. Okay, so in this case, in A, her kayak's always pointed up that way, but the river pushes her down. Now her kayak will always be pointed that way, but part of it's gonna be pushed backwards, kind of. Okay, now this is 4.2 meters per second. And what she wants to do, if she wants to land directly across the river, she has to cancel out that 4.2 with that component of her velocity. Okay, so she needs to cancel that out. So the only velocity she has is in the y direction. And so if you think about this triangle we've created, that only happens if this is her speed, 6.4. Okay, and that, stop. Okay, because she wants her x component to be 4.2, and that happens in this triangle. So what we need is this angle right here. Okay, and that's it. So we have the opposite and the hypotenuse. So that's going to be sine theta equals 4.2 over 6.4. 4.2 divided by 6.4 sine. So that's 41 degrees. Okay. And so she has to head 41 degrees upriver in order to land directly across the river. Now, keep in mind that this works because she can move faster. She can paddle faster than the actual river. If the river was faster than her paddle, this would be impossible. There's no speed that she could, no heading that she could take that would land her across the river, directly across. Because if that were the case, like if this was 8.2, okay, you can't have a hypotenuse that's bigger than a side. Okay, so your hypotenuse, which is the kayaker's speed, has to be bigger than the actual velocity of the river. Okay, any questions about that one? No? So if that was the case, like sometimes it'll be like, if it was faster, then it would be like if you start here and start going that way, you would have to end up that way. Like it can't be a 90-degree triangle. Okay, so if this was 6.4 and this was 8.2, like I changed it above, then you wouldn't never land directly across because it can't be a 90-degree triangle, but you could land downstream. Okay, so we could have questions like that that are non-right triangles. But again, you just draw the triangle and solve it, so it's not too difficult, and you probably won't even have a question like that.
I have a question.
Yeah.
Do you not put the direction though, like north of?
Yeah, I guess I could. In this case, I would just say upstream, because it's like it's intuitive that you would have to go upstream in order to land directly across.
But if you were
and if you were to write just 41 degrees with a picture like this, I would still mark it right, as long as you had that diagram.
Okay.
But yeah, if you were to do 41 degrees with a cardinal directions, then it would be 41 east of north. Like that. That's probably the best answer. So.
Right.
Okay. Airplane is flying 480 kilometers an hour, 20 degrees north of east. There's a wind blowing. Was that supposed to be west? Let me think about this for a sec. East of north. Oh, whatever. What is the new velocity of the airplane? So these ones they're not that tricky, but like the velocity of the airplane, I'm going to call it VR, the resulting velocity is going to be the velocity of the plane plus the velocity of the wind. Okay, and it makes sense. Like if you're flying in an airplane and there's a wind blowing, the wind is going to blow you in the direction that it's blowing. So you're adding that to the velocity. So this is a vector addition question. And so always somebody muted me. Please don't do that. Okay, so airplane's flying 480 kilometers an hour, 20 degrees north of east. So that's going to look something like, that's east of north, so I got to take that into account. Something like that. So that's 20 degrees north of east. And then we're adding the wind blowing 120 kilometers an hour, 34 degrees east of north. So that's going to be something like that. Okay, so this is 480. I drew this way too big. And this is 120. And then I'm going to close this vector. So there you go. Should have drawn that bigger. That's okay. So this right here, it is 34 degrees. 34 degrees. And then to find this angle here, it's going to be, so if this is 20, this would be 70, which makes this 110. There we go. So that angle is 110 plus 34, so that angle is 144 degrees. Does that make sense? Everyone understand how I got that? So what I'm doing is I'm imagining this vector as a closed triangle. So if this is 20 degrees right here, this is 90, which means this has to be 70. This line right here is straight. So that means it has to be 180 the total way around. So if that's 70, that has to be 110. 110 plus 34 is 144. So now I can say VR equals 120 squared plus 480 squared minus 2 times 120 times 480. And as with cosine law, it doesn't really matter what you mark as A and B or whatever. It's just, it'll work out regardless of how you set it. Equals minus 2 times 120 times 80 times cos 44 square root. Okay, so the answer is 581 kilometers per hour. Okay, so it's speeding the plane up, which makes sense because it's kind of in the same direction. And then we need the angle. So we're going to find this interior angle right here. We're going to use sine law to do that. So sine theta over 120 equals sine 144 over 581. And please stop me if I'm going too fast or you have no idea what I'm doing. Okay, so this angle is 6.97, so we'll call it 7 degrees. And so because that's this interior, oh man, this interior angle right here, 7 degrees, then if you add that to the 20, then up to that point is 27 degrees. So this is going to be 27 degrees north of east. Okay, so it's like, again, we've done questions like this already. It's just applying it to an airplane. And there's boats and currents and like, yeah, it's not always airplanes. And that's it. Any other questions? Okay, so plan for the rest of the day. Again, I don't want to get too far ahead because I'm anticipating new students coming in. Apparently they had 1,200 students added yesterday and they only got to like 500. So chances are we may get a few new students. And then, yeah, so I'm gonna, like, that's it, all we're doing today. So the worksheets are posted in the files tab. Kanwoo, I will email you, or I'll share those videos with you so that you can, hopefully works.
Thank you.
Could you share the videos with me as well?
Yeah, me too.
Okay, go to the chat function and just say, hey, I want the video. You know where that is?
Like reply in the video you posted?
No, so like go to this chat right here. This one?
Yeah, and send you a DM. Yeah, all right.
Yeah, and then send me, like, just, you go chat, or you can click this right here up top and just click new chat, type my name in, and I'll be there. And then just say, hey, I need the video. And if anyone else has problems accessing anything, just let me know. instead of emailing me all the time, use the chat function in Teams. It's easier. And then, so there's those 2 worksheets in the files tab, and I will be posting some questions for you to, like, for me to assess what you know at some point today. So you'll work on those as well. And again, with any questions, just let me know. So for today, I don't plan on meeting again at all. Unless you guys all have the same questions, then I'll start a meeting and go over those problems that you're asking about. But for now, that's probably all we'll do today. Any other questions?
You said something about a quiz.
Yeah, so I'll post something today at the end of, like, the class today, probably around 11 or maybe later. I don't know. We'll see. Yeah. And yeah, you'll see it on the main page. It'll just say, hey, like, this is the assessment I was talking about. Okay. Okay. I will see you guys, well, for sure tomorrow at 8:30. So that'll be the next lesson. But if we don't do anything else today, I'll see you guys then. Okay. Have a great day.